Hi everyone, this channel is about computer vision, and the modern frontier in computer vision is definitely robotics, and specifically world models. Yes, there are a lot of interesting works about edge computational, VLMs, stereo vision, some video generation. It's super interesting, but in robotics, everything is united, and robotics actually is the one core point where you can apply all this knowledge. I already did a few videos about VLAs on my channels, but I want to discuss world models today, and specifically DreamZero, the work from NVIDIA, which state that it's a breakthrough in world models. So let's check this out. Let's look at this work. Let's look at what people thinking, and maybe after this video you will get a little bit more knowledge about world models, about modern progress, the current problems, and so on. So let's start. So let's do some historical excursion. The term world models is from 2018, and originally the idea was kinda simple. So let's train a network, let this network memorize all knowledge about the world inside and generate some autoencoder representation of the world. And with this representation, we can train different neural network as a downstream tasks. So basically, we can create world from these small representations. Today, it's quite obvious idea. It's based autoencoders. We have a lot of them, especially in transformers, like transformers themselves are such representation of the world. With such a representation, we just can easily manipulate the world. We can train our neural network, something based on this representation, and we just can generate some sequences inside this representation. Why this is important? Because when we created such dimension, if it's represent original image, then we know that the whole information about original task and original image is compressed in this low dimensional space. And working with such low dimensional space, it's actually a little bit easier than work with big dimensions. And we 100% sure that we didn't lose any valuable information for our task here. So this was the original idea behind these world models. But actually today the idea is much bigger and more interesting. And let's look on this article from NVIDIA about DreamZero, which is their world action models. Actually, when you look in here, you need to understand that it's just a small part of models they creating for the last half of the year. And among such models, they created also pretty recent work, DreamDojo. It's like fully synthetic visual generation, like you drive this with one image of initial scenes and they generate in like your task after this with your actions. They have, of course, this Cosmos policy. It's previous work from NVIDIA. They have this NVIDIA Cosmos, which is video generation. And each of these tasks, for example, with this DreamDojo, utilizing weights from this NVIDIA Cosmos, and this dojo also utilized in this DreamZero, so it's a lot of stacked work and they pretty corresponding one with each other. And let's look on architecture of this DreamZero model. And actually architecture is pretty reasonable. Here it's like this video action generation, which probably is this DreamDojo. Also we have like encoded language model here. And during the inference, we generating from this all this world knowledge about our videos, our state, our command, we generating future frames. This model is pretty big, but it should be pretty fast because it's like optimized to this action generation. And during the generation of outputs, it's generating encoded data for the robot. and it's generating future frames. And after you see real images, you can just send this image for inferencing. Of course, these future frames, you actually don't need them for your inference. It's just an additional artifacts here. What they state that their architecture improving accuracy of classical visual language actual models almost 2 times by just 10 to 20 minutes of human demonstrations of such tasks, or 30 minutes of actions from different robots. You can fine-tune your models. And they state that it's working quite nice. Here they're showing a lot of graphs with this accuracy. What probably I want to say here, that different models that trained here, they were not optimized for these tasks. And of course, it's not 100% correctly to compare this model with older models, because older models, they were optimized for completely different tasks, and they just creating a new task and showing that their new model much better on this new task. And of course, it's like dramatically better on all this even unseen task. Actually, this result is pretty impressive. Even utilizing this for unseen tasks, it's pretty cool, because all other models, they pretty often failed on similar. But of course, for some specific task like transfers of actions from one robot to another, they are not excellent, and accuracy performance for them, it's not 100%, specifically for unseen tasks. And it's also still a big question if just their model is much bigger and incorporate much more information in it, either the architecture allows them to do such tricks. Anyway, this model is great in terms of how they could compress all existing information, like from this knowledge about the world outside us, about the different robots that exist, and just encapsulate this in one single architecture, which allow you to control the robot. But of course, when you're inferencing all this stuff, it couldn't run on your Jetson, and they state that for running this, probably you need some H100 or GB200 inference servers. And when I tried to run this DreamDojo on my 5070, it was super successful, because minimum H100 is required. It's starting downloading all their Cosmos models and other models, and to run this you need 80 gigabytes of memory, and for these models probably even more than that. But anyway, let's check what other people thinking about this model and its problem, and then discuss as a final. I found a few good discussions on this DreamZero article, and actually probably this article is one of the best. Here it's a lot of information aggregated, and the first information is accuracy that this model really have in comparison with peer 0.5. This accuracy is possible to check on two evaluations. One is Small Spaces and the second is Robot Arena. It's pretty similar to LLM Arena, and here you can run your policy on distributed robots in the world and check how accurate you will be. And in this leaderboard, the difference between DreamZero and P0 and P05, it's not so dramatically different as benchmarks from DreamZero showed. Actually, as I mentioned, when you have real environment and compatible task for your VLA and these world models, they are pretty similar. And authors also showed here then it's on specifically designed framework that's close to real task. This difference, it's not so dramatically different. It's not the same as here. And the other question author is raising here, it's DreamZero is utilizing much bigger backbone than previous model. But actually, in my opinion, here it's real super important trick, because when you utilizing the bigger framework, you need somehow to incorporate all this additional knowledge in this network structure. And maybe one of the most interesting question is how good this knowledge is packed here. And is it possible to use an existing technique and pack same knowledge into smaller model? The other question everyone is raising is how efficient policies that NVIDIA created for this DreamZero. And for example, if train the same model, everything, but without this visual generation as output like this, which making this DreamZero world model, how good it will work with the same policies, with the same domain knowledge, with same everything, but without this generation. Will it work the same, or you just don't need this generation? Actually, no one answered this question. World models, they are definitely interesting. And in my opinion, one of the best things among these world models that you just can look on how your model will run and just simulate how it will behave in your environment. When I saw this DreamDojo, why I created this video, I saw this DreamDojo model and wait a second, I just can run on my PC all these models, just prompt something and some random robot will show me a video how this robot will do this task. And actually, in my opinion, this is the most interesting part. It's like debugging, it's working with existing environment, and looking how your knowledge encapsulated already in this model. It's not about like some specifically accuracy, because as we see accuracy, it's not dramatically better when you're comparing actual states. And of course, if you need to maximize your accuracy, you just don't need to work with your models, you need to work with your robots probably. And here we just can look on a good example of explainable AI, where you're training your model, you're prompting it, and you understand what it's not working great. Because when you look on this DreamDojo video, which I previously showed here, you just can see some artifacts with video that's leading, for example, here, like it's incorrectly opening this laptop, and laptops are not behave like this. And it's exactly how you can understand, okay, then I don't have enough data with this, I need to append additional data here. It's good explanation for real engineers who will work with such models in the real production, what is going wrong. And in my opinion, all this generational stuff, it's just allowing you debug your model easier. For now, it's maybe not the most critical issue for such models, because the accuracy actually is pretty low. If you look on all these challenges or all these tasks, pretty often actually final accuracy it's within 20% of fully success rate. Of course, it's growing, everything is improving here and right now. In my opinion, world models here, it's a nice visualization and nice balance between the real world and between this scientific world with all this progress. So let's look at the progress. It's quite interesting. Thank you for watching. Bye.